hardware today. Zero 007. If you are present, if you are having mic issue, write in the chat box at the same time when I am calling your roll number. 138. 171.
Present, sir.
237. 237. 273.
Present, sir.
Someone 171 is present, I think.
Yes, sir.
Okay, 273.
Yes, sir.
308. 534. 622. 652.
Present, sir.
768. 1053. 1158. 274. 510.
Present, sir.
533.
Sir, 510 present.
Yes, already marked. 561.
Present, sir.
565.
Present, sir.
581.
Present, sir.
596. 596. 598. 599.
Present, sir.
617. 746.
Present, sir.
792.
Present, sir.
799. 821.
Present, sir.
855. 864.
Present, sir.
970. 2016.
Sir, C is present, sir.
Where is C?
Sir, Wi-Fi reboot करने की वजह से.
2039.
Present, sir. Present, sir. Usha Malik, sir.
2040.
Present, sir.
2246. 2406.
Present, sir.
2411. 2446.
Present, sir.
2461.
Present, sir.
2605. 05. Someone written in the chat box?
Yes, sir. 2039.
2039. Okay, already done. 2617.
Present, sir.
2637.
Present, sir.
2649.
Present, sir.
2669.
Yes, sir.
2673.
Present, sir.
2677.
Yes, sir.
2679. 2682.
Present, sir.
2683. 2709.
Present, sir.
Sir, 2683 present.
2683 present.
Yes, sir.
2720. 2722.
Present, sir.
2725.
Present, sir.
2731.
Present, sir.
2739.
Present, sir.
2821.
Present, sir.
2823, 2853,
Present, sir.
2863,
Present, sir.
3203,
Present, sir.
3205,
Present, sir.
3210, 3212,
Present, sir.
3213,
Present, sir. Present, sir.
3218,
Present, sir.
3223,
Present, sir.
3232,
Present, sir.
3237, 3242,
Yes,
Sir,
sir, present,
210
sir.
present, sir. I wrote in chat box.
3242,
Present,
present.
sir.
3250,
Present, sir.
3336, 3336, 3340,
Present, sir.
3345,
Present, sir.
3346,
Present, sir.
3362,
Present, sir.
3368,
Present, sir.
3382, 3383,
Present, sir.
3425,
Present, sir.
Sir, 2105237 present. Mic was not working. I wrote in the chat box.
Sir, 534 present.
534, present.
Sir,
Sir,
237 present.
596.
1596.
This is a problem. You can see this problem. I will take attendance again for all. Three machines, M1, M2, and M3 produce identical items. We have discussed about Bayes theorem, if you remember. Am I right?
Yes.
Yes, sir.
Yes. So three machines, M1, M2, M3 produce identical items. Of their respective outputs, 5%, 4%, and 3% of items are faulty. On a certain day, M1 has produced 25% of the total output, M2 has produced 30%, and M3 the remainder. One minute, let me see who has written in the chat box. 11, 11, 11, 12. 5237 1158. Let me complete. Three three eight two. Five two three seven. Five two three seven.
Yes, sir.
Why have you commented your roll number at the last?
Sir, I commented in the first, sir.
37. Okay, you commented at the first. Fine. 11, but still you were late. You commented
Yes, sir.
at
Mic issue, sir. Sorry, sir.
56. I will see. Can you see this problem? Three machines M2, M1, M2, and M3 produce identical items of their respective outputs, 5%, 4%, and 3% of items are faulty. So whatever amount they produce, out of those amount, 5% of M1 products are faulty, 4% of M2 products are faulty, and 3% of M3 products are faulty. On any day, it is written that M1 has produced 25% of the total output, M2 has produced 30%, and M3 the remaining. So M3 has produced 3 to 5, means 45% of the remaining is produced by M3. An item selected at random is found to be faulty. So it is given that an item is selected and it is found faulty. What are the chances that it was produced by the machine with the highest output? Who is giving the highest output? Machine 3. Because machine 1 is producing 25%, machine 2 is producing 30%, machine 3 is producing rest, remainder, means 25 plus 30. How much? It's 55. So 45% is produced by M3. Can you solve this problem? Suppose I am giving that A is an event. Let A is an event that item is faulty. Okay. And considering BI equal to item produced by MI, machine I, for I equal to 1, 2, 3. So B1 means B1 is giving you the item that has produced by machine 1. If I equal to 2, it's B2, item produced by M2, machine 2. And I equal to 3 means item is produced by I equal to 3 means it's B3, and it means that item is produced by M3. So can you find the probability? What is required? What is the chance that it was produced by a machine with the highest output? Who is having the highest output? Machine M3. So what are given here? We have probability of B1. Can you please give me this value?
0.05.
0.05. This one. Probability is B1 is the amount of items produced by machine 1. So machine 1 has produced 25% of the total output.
Oh, sorry, sir. 0.25.
0.25. Probability of B2. 0.30.
30.
Probability of B3.
0.45.
0.45. Rest out of 100%. 55% is produced by B1 and B2. 25% by B1 and 30% by B2. So total is 55% produced by B1 and B2. Rest is by B3. What is given? It is given that machine 1, 2 and machine 3 produces items of their respective output. 5%, 4% and 3% items are faulty. Means probability that it is produced by machine 1 and it's faulty. A is the event that item is faulty. So probability of A given that it is produced by machine 1, its probability is given as 5%, means 0.05. Probability of A, it is faulty and produced, it is given that it is produced by machine 2, M2, its probability is 0.04, and A given B3 means the item is faulty and it is given that it is produced by machine 3, its probability is 0.03. So what you need to find here, can you please tell me what is required? You need to find probability that it is given that the item is faulty, means A is given. Then what is the probability, what is the chance that it was produced by machine with the highest output? Who is having the highest output?
Third one.
Machine 3. So B3. This is what we want. Can you please give me the answer? It will be like A given B3 into probability of B3 by probability of A. This probability you can obtain using which one? Law of total probability. Means you can rewrite it as probability of A given B3 into probability of B3 by summation probability of I equal to 1 to 3, probability of A given BI into probability of BI. Can you find now? Give me the answer. Probability of A given B3. Which one? Is this one?
Yes, sir.
So this probability is 0.03 into probability of B3 0.45. 0.45. What should be in the denominator? Probability of A given B1 into probability of B1. It should be probability of A given B1 into probability of B1. It is B1 plus probability of A given B2 into probability of B2 plus probability of A given B3 into probability of B3. Can you find it? 0.03 into 0.45 by 0.03 into 0.45 plus second one 0.04 into 0.30. This into this 0.04 into 0.30 plus 0.03 into 0.45. Give me this value. What is the value? Anyone?
Sir, is it 0.355?
Yes, sir. 0.355.
0.355. Yes, it should be 0.355. Got it? Anyone else got the same answer?
Yes, sir. This is.
Solve this one. This is for you. You may consider it as class work. You have to solve it now. At a certain gas station, 40% of the customers are regular gas users. A1. 35% use plus gas. A2. And 25% use premium gas. Event is A3. Of those customers using regular gas, only 30% fill their tank. It's a event B, if they fill their tank or not. So event B. Of those customers using plus, 60% fill their tanks, whereas those using premium, 50% fill their tank. Fine. Next, these three answers, these three problems. Answer of these three problems. What is the probability that next customer will request plus gas and fill the tanks? Means you need to find the probability of A2 intersection B. Next, what is the probability that next customer fill the tank? It may be, the customer may be of gas 1, that is regular gas user. It may be plus gas user. It may be premium gas user. So B is what is the probability that customer fills the tank. Means you need to find the probability of B. This is what you need to find here. If the next customer fills the tank, what is the probability that regular gas is required? What is the probability that premium gas is requested? It's not required, requested. If the customer fills the tank, means probability, it is given that he fills the tank, then what is the probability that regular gas is requested? Regular gas means A1. So you need to find this probability, and you need to find request plus and premium. So you need to find this probability of A2, and you also need to find this probability of A3 given B. Find this. This is for you. I'm waiting. You start solving it now. Are you doing it or not? Not.
Yes, sir.
Yes, sir.
Do it. All of you do it. This course is easy if you follow the things. If you don't follow, it is going to be difficult when it gets accumulated. सब जमा होगा तब difficult हो जाएगा. इसलिए सारे चीजों को करते ही जाना है, छोड़ना नहीं है किसी को. Do it. I'm waiting for you. You have 10 minutes maximum. First one, you can get it using multiplication rule. Second one, you can get using law of total probability. And the third one, you can solve it by using Bayes theorem.
Sir, first one 0.105.
First one 0.105. Okay, fine. You calculate it, and let others calculate it. Then I'll match it.
Okay, sir.
But you got for A 0.105.
105.
This one is probability of A2 given B. Sorry, A2 and B. So you can rewrite it as probability of A2 B given A2 into probability of A2. B given A2 A2. A2 is, of course, customer using plus 60% of a failed tank. 0.60 into A2 is 0.35. What is this? 0.65, 0.6 into 0.35. It should be 0.21.
Yes, sir.
Yes, sir.
B and C.
Yes, sir.
What is the probability that the next customer fills the tank? You need to find the probability of B, probability that it's a regular gas user and fills the tank.
Sir, 0.455.
It may be probability that a 2 gas user and fills the tank.
Sir, 0.455.
0.455. Yes, that's right. C. If the next customer fills the tank, what is the probability that regular gas is requested? What is given? It is given that customer fills the tank. B is given. And you need to find the probability that regular gas is requested, or plus gas is requested, or premium. So three parts of this problem. Probability that A1, given that event B, probability of A2 plus gas requested, and it is given that customer fills the tank, that is given B. Similarly, probability of A3 given B. So you need to find these three. Probability of A1 given B, probability of A2 given B, probability of A3 given B.
The first one is 0.263.
Yes, that's right. 0.264. Okay. That's right.
0.461 second one.
0.462. Okay, fine. That's right.
And sir, 0.274.
Yes, that's also right. This one is 0.64, 0.462, and this one is 0.274. That's right. How to calculate it? You can use this V given A1 into probability of A1 divided by probability of B given A1 into probability of A1 plus probability of B given A2 into probability of A2 plus probability of B given A3 into probability of A3. Got it? So this denominator part will be same for all. I am writing it as P of B. And in the numerator part, it will change as probability of B given A2 into probability of A2. Similarly here, it will be probability of B given A3 into probability of A3 divided by P of B. I'm writing P of B or I'm writing this long expression, both are actually same. And these are the values that you will be getting. Let me give something, one more problem, or let me go to some. Okay, let me tell you about independence of events. Okay, there are many problems, you can solve it from the book. Next is independence. Independence. Okay. So let me give you independence of two events. Two events A and B are independent. Two events A and B are independent if probability of A given B equal to probability of A and are dependent otherwise. Means if something is known to you, if B is known to you, but it is not affecting your probability. Like, suppose I am saying, if it rains, the crop production will be higher. Then it's a kind of scenario that you can call it as dependent. अगर बारिश होगी तो धान की खेती थोड़ा ज्यादा होगी, बारिश नहीं होगी तो धान की खेती नहीं होगी. तो एक दूसरे को वो एक्चुअली इम्पैक्ट कर रहे हैं, वन इज इम्पैक्टिंग द अदर. सो दैट इज अ सिनेरियो ऑफ dependent events. Suppose if I say that if India wins T20 World Cup, it is given to us. Suppose it is given to us that India wins the T20 World Cup, then the crop production, what is the probability of crop production? Will that two are anyhow related?
No, sir.
No, sir.
So in that scenario, if B is given that India wins T20 World Cup and A is an event that is the amount of crop production, you can directly say that this probability of A given B is actually probability of A. The crop production will not be affected by India wins the T20 World Cup or lose it. Got it? So that is the scenario actually. So the main thing to note here that the given event is not impacting A. For your understanding, I'm writing it, not impacting A. The given event is given event is not impacting, or I can say has no impact on A. Then we can say that event A and B are actually independent events. So if possible, let me see if I can take one example. Yes, I have one example. Let me give you an example. Consider a gas station. Consider a gas station with 6 pumps. Numbered as 1, 2, 3, 4, 5, and 6. And let EI denotes an event. Denote the simple event that are randomly selected customer uses pump I. I may be 1, 1, 2, up to 6, any of the pump. So if E1 means the customer is using the first pump, E2 means customer is using the second pump, E3 means customer is using third pumps, and so on. So suppose we are given like probability of E1 is given as probability of E6 equal to 0.10, probability of E2 equal to probability of E5 is given as 0.15, probability of E3 equal to probability of E4 is given as 0.25. These are given. Now I am defining some events, define events A equal to 246, B is an event, it's defined as 1, 2, 3, and C is an event where I'm considering 2, 3, 4, 5. Now the probability of A, here you can see that probability of A equal to, what is it? 3 events are there, 2, 4, 6, 3 are left out of 6. So this is 0.05, 0.50, and probability of A given B, probability of A given B is probability of A intersection B by probability of B. Is it fine? Clear?
Yes, sir.
Yes, sir.
So probability of A intersection B, you can take the A intersection B. What is there in this intersection part? Only 2. Only 2 is there common in A and this and B. And what is the probability of B? It is 0.5. So this is, I think, 1 by 6, and this is 3 by 6. So this is going to be 1 by 3 or something. What will be this probability? Let me check. Probability of A intersection B. A intersection B is only 2 is common. Given B. Three, 1 by 3, 6. What should be this probability? You can check for this, but this is coming as 0.30. How? You will tell me. Similarly, if I find the probability of A given C, this is probability of A given C. Probability of A intersection B by probability of C is equal to A intersection B. What is common? 2, 4. If I use 2, 6, 2 by 6, C is 4 by 6. So it is
5.
2 by 6 into 4, 6 by 4, it is 0.5. This should be, let me check, 1 by 6. Let me check it. 1 by 6 into 6 by 3. So this will be 0.33 somewhere, I think. Yes. Let it be whatever it is, 0.3 or 0.33. This, what you can see here, probability of A equal to probability of A given B. Is it right? This is 0.50, this is 0.33. Not right. Similarly, if you see probability of A equal to probability of A given C, these are actually same. So these two events, this implies A and C are independent. And here, this implies A and B are dependent events. Got it? Clear?
Yes, sir.
Yes, sir.
No. So next I have one proposition. It's just using the independence with the multiplication rule actually. So you can have one formula.
So can you please share
calling
the
it as
previous slide?
proposition. Yes.
Yes, sir. Done. Thank you.
That
Yes.
proposition, that is A and B are independent. Events A and B are independent if and only if, or you can write like IFF also for this, if and only if. This is probability of A intersection B. You can write it as probability of A into probability of B. Got it?
Yes, sir.
You can think of like this: probability of A intersection B equal to probability of A given B into probability of A, this is by multiplication rule. This
Probability of A or probability
then you
of B.
also know that probability A and B are independent if A given B equal to probability of A and B are independent if this. So combine these two. If independent, then A given B, this can be replaced by probability of A.
Yes.
Probability of A given B is probability of A. Clear?
Yes, sir.
Yes, sir.
Using, let me call it equation 1, let me call it equation 2. Using 2 in 1. I am giving this value, probability of A given B equal to probability of A in 1. So you will be getting this one, probability of A intersection B equal to probability of A in place of probability of A given B, because this is same as probability of A into probability of B. This is the same one. Clear?
Yes, sir.
I have some problem also, but let me give you another definition. Like, I have considered two events. There may be multiple events, and we can check for their independence also. So events A1, A2, suppose I have AN events are mutually independent if for every k may be 1, sorry, not 1, it should be 2, 3, 4, up to n. So any pair or any triplet or any 4, any n number of, even you can take all of them together, and every subset of indices I1, I2, IK. Actually, I am just, this I1, I2, IK are actually a kind of numbered events. I am just giving them a kind of numbering of these events. Okay, then the probability of A1, sorry, AI1 intersection AI2 intersection AIK, this will be independent, mutually independent, if you can write them as I1 into probability of AI2 into probability of AIK. You can take any two, like A1 and A2 are mutually independent, that I have just written in this one. You can take 3, A1 intersection A2 intersection A3. These 3 are independent, A1 and A1, A1, A2, and A3 are independent if probability of A1 intersection A2 intersection A3 can be written as probability of A1 into probability of A2 into probability of A3. Similarly, if you try to check for A1, A2, A3, A4, this will be probability of A1 intersection A2 intersection A3 intersection A4 is going to be probability of A1 into probability of A2 into probability of A3 into probability of A4. Clear? Any question?
Yes, sir. No, sir.
Okay. So I'm stopping here.
Okay, sir.
Okay. Thank you all of you. I have already taken the attendance.
Thank you, sir. Have a nice day, sir.
Okay. Thank you all of you. Have a nice day.
Thank you, sir. Excuse me, sir.
Yes.
So can you please mark 274 present? There was some network issue. That is why I joined late.
Network issue, or you joined
Sir,
late?
I wrote in the chat box earlier also.
So because of network
5-9.
issue, I joined late. Excuse
So
me, sir.
1596.
Only this
Sir,
only
274.
3 persons has written Oh, some are more there.
Excuse me, sir.
Yes,
Sir, row number 598 present.
598.
Yeah.
Yes, written in the chat.
274 present.
Yes,
So Vaishnavi.
I will see those who have written in the chat box before this 11:15.
Excuse me, sir.
Yes,
Sir, I was not there in the starting, but because of network issue, then I joined late. So please mark me present. I have not written in the chat box also.
then I will have to take the attendance of all again.
So,
2039.
so my name is Vaishnavi Verma.
2039. Wait. 598. Sneha Saha. 598. Sneha Saha.
So 274 Vaishnavi Verma.
Wait.
The 596 as well.
3210. 3210. Already done.
So 1617 present.
3237.
So 1617.
I'll mark only those who have written here in this chat.
So sir,
15.
can I write there?
No, you don't need to write now. 1596.
Please mark me present because I was having some network issue.
Everyone says the same. How to manage that,
Sir, I joined at 11:23.
5
That
to
is why
7.
my Wi-Fi was not working because of